Hi, this is Sam at the Aprovecho Research Center. We're looking at the laboratory emissions monitoring system. It measures carbon monoxide, carbon dioxide, and particulate matter. When it was originally created, it used only a light scattering sensor to measure particulate matter. And then, with increased standards and desire to have better accuracy, we added a gravimetric system. And the gravimetric system consists of a large vacuum pump, cyclone, filter holder, and critical orifice. Now there's more attention to measure black carbon, and there's been a new development from Nexleaf analysis that allows us to do that.
While our BC sampler will work with any type of black carbon analysis, Nexleaf Analytics has produced these reference cards which allow us to inexpensively and simply take a photo of the black carbon filter and then upload it to their server and quickly get a response for the amount of black carbon.
With the reference card, you're able to take a picture of the filter and upload it to the Nexleaf servers for analysis. I'm showing you the tripod and the camera setup that I have because it's important to have a diffuse light source. There's a common error where there's a glare on the card and it makes it so the analysis doesn't work. Looking at a collection of filters that came off of the lens. The Nexleaf analysis only works for the medium darkness filters. It often reports overloading or underloading errors for the cleanest filters. That's why we had to create a different sampler. While it is possible to use the filter from the gravimetric system with the Nexleaf analysis, we won't be able to measure all different sizes of cook stoves. There's clean and dirty stoves, and there's large and small stoves, and they all put a different loading on the filter, just like we saw with the grid of filters. To be able to measure very dirty stoves or baseline stoves, or even very, very clean stoves, to be able to sample for black carbon, we had to create a new component. And in order to measure those dirty stoves, we have to have a lower filter loading. And so to do that, we can use the same size filter, but sample at a lower rate. The sampler that we created goes at 3 liters per minute instead of the 16 liters per minute of the gravimetric system. Now when we use the same diameter filter housing, it lowers the density, it lowers the filter loading. So that covers us for the dirtiest stoves, even for baseline stoves or stoves in the tier 0 to tier 2 range. And for the very cleanest stoves that we might see in the future, you can also put in a smaller filter, a 47 millimeter filter, in the gravimetric channel, which is sampling at 16.7 liters per minute. So with these additional components, with a smaller critical orifice, a separate sample train with the smaller cyclone, a separate sample port inside the duct that's isokinetically sized. With those additional components, your lens will be able to sample all different sizes of stoves, all different cleanliness of stoves for black carbon.